Hello students, welcome back to my channel once again. Those who are watching for the first time, please subscribe my channel which is named as Mary Afia so that you will not miss any of my new videos that I am uploading. This video I am going to explain you what entropy is and what change of entropy in reversible process and also an irreversible process. In the last video, I have explained or I have given you limitations of first law of thermodynamics. What does it mean, students? What all points that first law couldn't explain and what led to second law of thermodynamics? So all those points I have discussed in the last video along with spontaneous and non-spontaneous processes and also few examples I have quoted over there. Hope you have watched that video. If you have not yet watched, please go back and watch that video so that you will understand easily this entropy. Okay, so this is a very important topic which I am going to explain in this video. Kindly open your notebook, students, and put the side heading entropy. What is meant by entropy? Entropy, it indicates or it tells us the disorder or the randomness of arrangement of molecules in a system. Okay, so wherever there is disorder, wherever there is no uniformity in the arrangement of the molecules, we call it as entropy. Okay, so entropy of a thermodynamic system, it speaks about randomness or disorder of molecules in a system. That is the first point you have to mention, students. Entropy of a system indicates randomness or disorder of molecules present in a system. So, if you are asked, define entropy, a one word answer you can define or you can give like this. That's the second sentence I have mentioned here. A thermodynamic quantity which is a measure of disorder or randomness of molecules in a system is called as entropy, which is denoted by the letter capital S. Okay, so by this time you must have understood entropy is equal to disorder, right? And coming to the characteristic features, entropy, it is a state function. What is meant by state function? Go back to the first classes of thermodynamics. There you can find what a state function is. State function is nothing but which depends on initial and final states of the system. It is not dependent on the path followed how the initial state is converted into a final state. Okay, so it is not path dependent. That's why we call it as a state function. And here entropy comes under state function. Okay, next point you can write down. It's a state function as it depends on initial and final states of the system. Next, students, generally change in entropy of a system is given by, so entropy is denoted by the letter S. Change in entropy is denoted by delta S. So delta S is equal to final entropy minus initial entropy, where we denote final entropy by SF and initial entropy by SI. Therefore, delta S is equal to SF minus SI. And also you mention where SF is final entropy and SI is initial entropy. That is the next point, students. And also delta S, that is change in entropy, is given by or is equal to Q by T. You all know Q is the total amount of heat absorbed or released. So delta S, change in entropy, is the ratio of, from the formula, total heat absorbed reversibly and isothermally. What's the meaning isothermally? Temperature is kept constant. So it can also be written as delta S is equal to Q reversible. Q reversible means heat absorbed reversibly by temperature. Okay, students, clear? So I have given you the definition, its characteristic feature, and also the expression for change in entropy. We can write it as SF minus SI, and it's also given a formula or an expression Q by T, where Q is the total amount of heat absorbed reversibly and isothermally. So from this we can write it as delta S is equal to Q reversible by T. Next comes, students, below write down if SF is equal to SI. That means final entropy is equal to initial entropy. Then delta S value will be equal to how much? Taking SF minus SI, if both are equal, then delta S value will be equal to 0. Suppose if SF is greater than SI, 80 minus 20 is equal to 60. So delta S value will be equal to positive. Suppose if SF is less than SI, 60 minus 80 minus 20, then delta S will be equal to negative. Okay, so write all these three, students. SF is equal to SI, delta S is equal to 0. If SF is greater than SI, then the value of delta S will be positive. If SF is less than SI, then delta S is equal to negative. All these we have done taking the formula delta S is equal to SF minus SI. Okay, next below write down delta S is positive for a spontaneous process. In the last video, we have seen what a spontaneous process is, which takes place or which occurs on its own without taking any external assistance is a spontaneous process. So, for these spontaneous processes, change in entropy value will have a positive sign, and delta S is negative for a non-spontaneous process which cannot take place on its own, which needs some external assistance to take place. Written next. So now we all know that entropy is a disorder or randomness of molecules in a system. Next point, write down system. Write down, students. More the disorder of a system, higher is its entropy. So, if the irregularity of the molecules in a system is high, then its entropy also will be high. So, that's the meaning of more the disorder, more the entropy. Next, in that sentence only, you continue. An increase in entropy during a physical or chemical reaction. What does it mean? An increase in entropy. In a physical or chemical change or in a physical or a chemical reaction, if there is an increase in entropy, if there is an increase in disorder of the system, it means that the system is more disordered in its final state when compared to its initial state. Okay, so it is more disordered in its final state when compared to its initial state. Also continue there, all spontaneous or naturally occurring processes, they lead to increase in entropy. Okay, students, understood this point? So once again I am repeating, more the disorder of a system, higher is its entropy. An increase in entropy during a physical or a chemical reaction means the system is more disordered in its final state than in its initial state, and all spontaneous processes lead to increase in entropy. Written this point. Next point, write down. We have seen that entropy is a state function, which means that it depends on initial and final states, but not on the path followed, how the final state is being reached. And also, it is an extensive property. This also we have discussed in the initial classes, students. Entropy is an extensive property. What does it mean? It means that it depends on the amount of the substance involved in the reaction. So, entropy is an extensive property as its value depends on the amount of the substance. Written that point also? Clear? Take a screenshot, students. Entropy is an extensive property as its value depends on the amount of the substance. So, if you are asked to write about entropy, you can write all these points. So, what are points you have to write? Entropy of a system is a thermodynamic quantity which is a measure of disorder or randomness of molecules in a system, which is denoted by capital letter S. It is a state function which depends on initial and final states of the system, and change in entropy delta S is equal to SF minus SI, and also it's given by an expression Q by T, which is nothing but the amount of heat absorbed reversibly, which can be denoted as Q reversible by T. Okay, and also SF is equal to SI, SF greater than SI, SF less than SI. So, for a spontaneous process, underline, students, delta S is positive, and for a non-spontaneous process, delta S is negative. And also, more the disorder, more will be the entropy. Suppose if there is an increase in entropy during a physical or chemical reaction, it means that the final state has more disorder than the initial state. And also, all spontaneous processes lead to increase in entropy, and also it's an extensive property as its value depends on amount of the substance. Next, put the side heading, students. Entropy changes in reversible process. So, if you are asked, write about change in entropy in a reversible process, then you are supposed to write what all points I discuss now. Okay, put the side heading, kindly underline entropy changes in a reversible process. Now, suppose let us consider that a process is occurring reversibly. Okay, so what's the meaning that the process is taking place reversibly? Means heat is absorbed by the system reversibly and heat is lost by the surroundings reversibly. So whatever heat is lost by the surroundings, all that heat will be taken up by the system. You know that system is surrounded by surroundings, right, students? So, if we assume that a process is taking place reversibly, then heat is absorbed by the system reversibly, and whatever heat is lost by the surroundings, that will be same as the heat absorbed by the system. So, both you can see here I have mentioned reversibly. Heat absorbed by the system reversibly, heat lost by the surroundings reversibly. Can you see the first point, students? So, please write down. Let us consider a process which is taking place reversibly. That is, heat is absorbed by the system reversibly, heat is lost by the surroundings reversibly. Next point, write down. Let us suppose the heat absorbed by the system reversibly is Q reversible. Write down, students, capital Q. See, I have written here. Let Q reversible be the heat absorbed by the system reversibly and Q reversible be the heat lost by the surroundings reversibly. Written? Second point. So, third point. If the process takes place at constant temperature, T, capital T. That means there is no change in temperature. So, under that conditions, change in entropy of the system, we denote it as, students, change in entropy, we denote it as delta S. But now we are taking change in entropy of the system. So, how to write delta S? System is equal to Q reversible by T. Mark this as equation number 1. Next, below, change in entropy of the surroundings. Here we have written delta S system. Here it has to be written as delta S surroundings. So, which is equal to, here this is the heat absorbed by the system from the surroundings, and here this is the heat lost by the surroundings. Therefore, we mention it as minus Q reversible by T. Got it, students? This is the heat absorbed. So, positive sign. This is the heat released. So, minus sign. Mark this as equation number 2. This is change in entropy of the system, change in entropy of the surroundings. So, if I need total change in entropy, then what I have to do? I have to add delta S system and delta S surroundings. So, below I have written, see students, total change in entropy, delta S is equal to delta S system plus delta S surroundings. So, we have these two values. So, delta S system, you substitute Q reversible by T, and plus delta S surroundings, it is minus Q reversible by T. So, it becomes equal to Q reversible by T minus Q reversible by T. Plus into minus is minus. So, both gets cancelled, is equal to 0. So, finally, delta S is equal to 0 in a reversible process. Okay. So, how delta S is 0 in a reversible process? Hope you understood, na students. So, at the end, you write down, thus net change in entropy of, net change in entropy of a system and surroundings in a reversible process. Change in entropy of a system and surroundings in a reversible process is observed to be 0. Brackets, delta S is equal to 0. Close the brackets, that is, it remains constant. So, in a reversible process, there will be no change in entropy. Why? Because the amount of heat lost by the surroundings and the amount of heat absorbed by the system will be same. Got it, students? So, this is about entropy changes in reversible process. So, students, those who have not written the last sentence, you please copy down. Right. Next. Now comes change in entropy in an irreversible process. In the brackets, also mention it as spontaneous process. Okay. So, till now we have learned entropy changes in reversible process. Here we will see entropy change in an irreversible process. Underline irreversible process, bracket, mention it as spontaneous process. Okay, spontaneous process. Underline, right. So, students, each and every reversible reaction, it turns into an irreversible process even if one part of it becomes irreversible. Carefully listen. Every reversible reaction, it becomes irreversible even if one part of it becomes irreversible. You know what a reversible process is. Okay, it takes infinite time to complete. So, in this reversible process, somewhere if one portion of it, if it becomes irreversible, now the whole process becomes irreversible. That is the meaning of the first point. Written, every reversible process becomes irreversible even if one part of it becomes irreversible. Next, second point, students. Suppose if the amount of heat lost by surroundings, let us assume it to be Q irreversible. Because we are considering entropy change in an irreversible process, let us suppose that Q irreversible amount of heat is lost by the surroundings. So immediately what comes into your mind? The same Q irreversible amount of heat will be absorbed by the system, right? Yes, it happens. But students, change in entropy, it does not depend upon Q irreversible amount of heat lost by the surroundings, but change in entropy depends upon the heat absorbed reversibly. So heat absorbed reversibly is denoted by how much? Q reversible. That's what the next sentence means. Right on. Although this heat would be absorbed by the system, change in entropy of the system depends on the heat absorbed reversibly, that is Q reversible. That is the third point. Below write down. Therefore, entropy change of the system at absolute temperature capital T will be delta S system is equal to Q reversible by T. Below write down. Change in entropy of the system at absolute temperature T is given as delta S system is equal to Q reversible by T. Now, I will ask you one question. What would be the entropy change of surroundings? How to write entropy change of surroundings? How will you denote? Here we have taken delta S system. Entropy change in surroundings, delta S surroundings is equal to what to write here in this place? Q reversible by T. Look at the second sentence. Let us suppose Q irreversible amount of heat is lost by the surroundings. So, entropy change of surroundings, delta S surroundings will be equal to minus Q irreversible by T. Very good. Those have written minus Q irreversible by T. Very good to all of you students. Those who have not written, please kindly write down below the next step. Entropy change of surroundings will be delta S surroundings is equal to minus Q irreversible by T. Okay. Now, total change in entropy, you have delta S system, delta S surroundings. So, this you can do on your own. Hence, total change in entropy will be delta S system plus delta S surroundings, which is equal to, don't simply copy down. Try to understand and write. What do we have? Delta S system, Q reversible by T. What do we have? Delta S surroundings minus Q irreversible by T. Okay. Mark this as equation number 1. Here we cannot cancel it because one is Q reversible, the other one is Q irreversible. So what to do now? Below write down. We know that W reversible. What is W reversible? Work done in a reversible process is always greater than work done in an irreversible process. And also we know that work done is directly proportional to heat absorbed or released. So in the place of W reversible greater than W irreversible, we can write Q reversible greater than Q irreversible. Why, students? Because work done directly proportional to heat absorbed or released. Okay? This sentence understood, na? Right. Below write down. Dividing both sides by T. Where to divide? Take this Q reversible greater than Q irreversible. Dividing both sides by T, we get Q reversible by T greater than Q irreversible by T, which can also be written as Q reversible by T minus Q irreversible by T. Okay, Q reversible greater than by T greater than Q irreversible by T, which also can be written as Q reversible by T minus Q irreversible by T, which is greater than 0. Mark this as equation number 2. Okay, so from equations 1 and from equations 2, we get total entropy change, that is delta S system plus delta S surroundings is greater than 0. This is delta S system plus delta S surroundings, which is greater than 0. So therefore finally write down delta S, that is entropy change in an irreversible process, is greater than 0. Put it in a box, students. Okay, so this is all about entropy change in a reversible process and entropy change in an irreversible process. Okay, so clear, students? Please note down all these points in your notebook, which is a very important topic. Entropy change in a reversible process and entropy change in an irreversible process. Okay, so thank you all, students, for watching. Please subscribe and meet you in the next video with a new topic. Thank you. Take care. Bye-bye.